Hi, welcome to the Olympiad geometry. Let's continue our study. Here I start a new series called XMO, which is represented for the problems from at least national level math Olympiad. Therefore, these problems can be considered as difficult ones. I received the audience feedback asking me when we are going to continue on the harder problems. Indeed, learning the theorems is on one side that can help us to making a solid foundation. On the other hand, we want to practice a lot. So I start this new series, and in the future, if the audience asks me about the national level or international level problem, I will put it into this series as well. I will start doing old problems first, just because it's easier for everybody, including audience and me. Okay, so let's start. Let ABCD be a convex quadrilateral with AB equals to CD. Let R and S be midpoints of set AD, BC respectively. Consider rays AUDV parallel with RS, and all of them point in the same direction. Show that angle BAU equals to angle CDV. This is 1952 Czech and Slovak Math Olympiad. Okay, so let's just draw the figure first. We want to have a convex quadrilateral with AB equals to CD. So if I draw AB like this, probably I need to draw CD like this, right? So here we have A, B, C, D. And RS be the midpoint of set AD and BC. So this one is R, and call this one is S. Consider rays AUDV parallel with RS. So we connect to RS, and we find the parallel line to RS. Right? And all of them point in the same direction, which means this is RS, then this would be AU, this would be DV. So actually, let's just naming this point as U, naming this point as V. It doesn't matter, right? Just to help easier for the future discussion. And we want to show that angle BAU equals to angle CDV. Okay, we want to show this angle equals to this angle. Okay. As a first glimpse of this problem, we know that we have some parallel lines, and we want to prove that two angles to be equal. But the most important problem set in this problem, in the first feeling, would be AB equals to CD, right? And RS are the midpoint of AD and BC respectively. So generally, when we see problem like this, we see that AB equals to CD. So we want to find a way to put them together to form an isosceles triangle. Right, so here we can do this. We can just passing through point B to find a parallelogram. Right, maybe I'm drawing it not in a good shape. Anyway, let's just think this as a parallelogram, okay? So let's call this point as X, okay? So now we find the parallelogram. BCDX. Right, because we know the edge BC, we know the edge CD, and when we do a parallelogram, we know that BX equals to CD, which means triangle ABX is an isosceles triangle, right? Because AB equals to CD equals to BX. Now we want to find the midpoint of AX. Let's call this point as E. We know that because triangle ABX is an isosceles triangle, so we know that BE is perpendicular to AX, right? And E is a midpoint of AX. Now we can see, because R is a midpoint of AD, so we want to connect ER, right? That means in the triangle AXD, ER is in parallel with XD. And because BCDX is a parallelogram, that means ER is in parallel with XD, also in parallel with BC, and also that means in parallel with BS, right? And because ER is half of XD, which is half of BC, which is half of BC, which is BS, right? So it also equals to BS. That means ERSB is a parallelogram. Right? If we connect ER here, we know that ERSB is a parallelogram, which means RS is perpendicular to AX as well. Which means because AU is in parallel with RS, so AU is perpendicular to AX. Right? So we know that EB is in parallel with RS and AU is perpendicular to AX. Which means angle BAU equals to angle ABE. Angle BAU equals to angle ABE. And equals to, because ABX is an isosceles triangle, so angle ABE is half of angle ABX. Which means it equals to angle XBE. Right? Okay, now let's think about this. What is angle ABX indeed? So we're looking for the angle, we're trying to prove that angle BAU equals to angle CDV, right? And if we just extend AB and we extend CD, right? Because DV is in parallel with RS and AU is in parallel with RS, which means the angle CDV equals to this angle, right? So this angle equals to this angle. And angle BAU equals to this angle. Right? What is the summation of these two angles? It's actually the angle formed by the CD and AB. Right? That means the angle, so let me explain here, the angle BAU plus angle CDV, right? Angle BAU plus angle CDV is actually this angle plus this angle, which you can think of that we have a parallel line here, right? So this angle equals to this one. And that means the angle BAU plus angle CDV is an angle formed by the CD and AB. And when we do a parallel line of the CD to BX, the BX form the angle with AB, that is angle XBA. So it equals to angle ABX. Now, if you look at this one to this here, we know that angle BAU equals to half of angle ABX, which means that angle CDV equals to half of angle ABX equals to angle BAU, right? Of course, this is not very difficult. It's just because it's an old problem. Think about that. I find this problem from the AOPS, and I also write the solution on this under this problem, so you can find my solutions there as well. I will put the link, like the first comment of this video. So what I want to say is that, of course, this is not a very difficult problem just because it's old, but think of, like, at that time, people have no information, right? So nowadays we are well improved compared to 70 years ago. So this is still a good practice problem. I hope you like it. And what I want to say, another thing is that AOPS is, I think it is founded in 2003, right? So that's basically my middle school age. So at that time, I don't even have a computer. I don't have internet. I cannot access all of this information when I do the math computation. So nowadays, students has so many useful websites to learn about. But I feel that people just spend lots of time on other things rather than a hard working or hard study. It's kind of pity. Anyway, you can find a lot of problems on AOPS, and I'll try to solve as much as possible on the AOPS for our XMO series. I hope you like this video. I hope you like this series, and see you in next one. Thank you.